Hello friends, today we are going to present our CIM project on design of vertical carousel rack for the calendar rubber sheet rolls. Here are my teammates Akshar Kakadia, Jay Patel and I am Urvesh Limbachia. The outline for the project is like basic like project backgrounds, designing and assembling uh, parts and model, DFM and DFA, and redesign of the model for based on the DFM and DFA. And so the here we go for the background. Here is a Lathia Industrial Company Private Limited in India. It is a usual. It is a based on the rubber steel rolled models, and they are storage a rack for the rubber sheet rolls over there, and it is a huge and the wild company in India. But here we are going to redesign for the redesign the storage rack for the rubber sheets. And for the further information, my friend Jay Patel going to say you something more.
Hello. Uh, Now, next going on with the designing and assembling. Here you can see that figures like firstly, that's a rubber roll which is inserted. That's a main part of our assembly, and you can see that how the rubber rolls with stands put it on stand. That stand is like width of the diameters of the rollers. And the second thing is that the trolley with the wheel, which consists the rolls and how that the trolley is putting in the stand. Next thing is the frame. The frame is like a 3 by 3 by 3 diameter meters circumference, and in frame like there is a 4 trolleys which we can put it together. So overall, thus the final assembly you can see as per figure, like we can put 16 rubber rolls on the frame. Next. And now the we are you can see that like how the parts and models are assembled to each other. Like there is the beams and the frames, the trolleys, the rubber rolls, and how they are put together and assemble. In this figure you can see that. The next thing is that the how we improvise this design for manufacturing. Like you can see that this is the conventional model of the drawing. You can see that like as I described ago, that's and this is the second figure is described on the right side is describe how we improvise the design, like with the improvised design. With this we are improvising the number of components, like reducing the number of components in the second figure, and reduce the number of parts basically because it's a vertically, that's why it's reduce the number of parts. Second thing is the develop a modular design, and it's also the easy to fabricate because there is less parts in this assembly. And last thing is that we can use it like a loading unloading purpose. So now the we are moving on design for assembly, like you can see that how we can improvise the assembly process. So design for ease of assemblies, like we improvise the manufacturing cost and simplify the design, reduce the number of part estimated of total cost for both structures. So basically we are doing just improvisations in designing of the conventional one to the vertical corrosional frame model, and it is really easy to fabricate this design because it only consists the minimum part of parts. Now moving on, Akshay Kakaria present.
Hello everyone. Uh, I'm gonna explain you the redesign of the model based on DFM and DFA. So what we did is we just created the vertical casserole stack storage stack for that. So it can save lots of space where we just put these things. So and also we just mm, improvise it with different mechanism of you can see here uh, belt and sprocket mechanism, which is very easier here shown here. Like we also did like pin and attachment mechanism on that. So every rod can take up one roll of the rubber, and also it is automated with the gearbox and motor mechanism. So just we can start the motor, and we can get any roll from upper side or downside, upper side to downside. And that's the easiness of this model. Let me explain you in the Fusion 360. So here is the model you can see here. So how it gonna work is like we just start the motor and gearbox with like it's for the speed reduction. The speed reduction rate for these is the 70 by 71 to 70. So it will reduce the speed of the motor, speed of the speed for the rounded sprocket. And right here we can see the drive and sprocket. Then another is another sprocket, which is like this is the connected mechanism. And for that we can just use like this little bit of space, and we can store 10 different roles on that. So it is very easier. And mostly we can also see we just did the estimation on the space saving on that all the things. After the modeling we just use the frame structure. It's a 3 by 3, and right here we just did another casserole, vertical casserole stack, and this is the 3 by 1. So after the calculation of all the things we just saved like 37%, 37.5% space in compared to the regular structure. So after I'm gonna this is the final model on based on DFM and DFA. So the conclusion is by using DFM and DFA method, vertical carousel is contain less part in assembly and uh, less spacious than conventional one. The increased cycle time for loading and unloading of material, which leads in a more efficient production. In the end it increased the production rate of the manufacturing. This storage rack also, like they manufacturing their fabrication unit. So we just did this project on that. Thank you so much all.